Hello, good afternoon. Can we start? Who all are there? Please let me know. Please type in your name, all of you. Shruti, Ritvik, Sai Mihir. Sai Mihir, did you understand that question? You have asked one question, no? That has been asked in JEE main exam. You were saying the answer should be C and D, Ni2 plus and CO2 plus. The given answer is correct. Option D or fourth option is correct into that one. Did you understand that? Yeah, because Ni2 plus will never form low spin octahedral complex. That's why that is not the answer. Right? In CO2 plus, the electron may excite into the 4d orbital. That's the reason we have. Okay. So today we are going to solve some questions of hydrocarbon chapter. Okay. So we are probably going to solve 40 to 45 questions today in this session. Okay, all are from hydrocarbon. Right? So the first question, you see it is there on the screen. Try this one and tell me the answer. Naman is getting B. Ritvik is getting B. Saimir is getting B. What about others? Tell me what should be the answer in this. First, keep in mind for Wood's reaction. Generally, Wood's reaction is used for the preparation of symmetrical alkane. Symmetrical alkane, right? It is the method for the preparation of symmetrical method. And that is only possible when you take same alkyl halide. Suppose we will take 2 moles of Rx, then 2 Na in presence of dry ether. Then the product will be RR, right? But we take two different alkyl halide, R1X plus R2X with Na and dry ether, right? All these reagents are same. Then the possible product here, it will be R1 plus R2, R2, and R1, R2. These are the three possible product we'll get into this. Okay, all possibility we'll have over here, right? So this is what happens when we have two different alkyl halides. So total three alkanes will get 1, 2, and 3. And this is what we have here. Since the question contains, we have ethyl iodide and propyl iodide. So propane and propane combines forms hexane. Ethyl ethyl combines forms butane, right? So butane possible, hexane also possible. And when ethyl propyl combines forms pentane, right? That is why propane is not possible in this case. Answer is option B, right? This you must keep in mind. They have asked one question, this one, that how many products are possible in this reaction, right? So always you remember, different alkyl halide gives you three different alkane, so three product possible here, correct? But in this question the answer will be option B, right? Next question, you see, solve this one. Try this. Aditya is getting B, Samir D, Shruti D. Okay, first of all, you see, LiAlH4 is not possible because what it gives, it converts acid into alcohol, correct? So this is not possible, option A. It is a reducing agent, reduces acid into alcohol. Soda lime is generally used when we have salt of any acid. Like suppose if you have CS3COH, CS3CONA, salt of this, and when it is heated in presence of soda lime, NaOH, and we also use CaO over here because soda lime we have a mixture of these two, and when we heat this, decarbox decarboxylation takes place, right? Or Na2CO3 comes out into this, and the product we get here is CH4 plus Na2CO3. Na2CO3. Carbon dioxide evolves. So soda lime is also used when we have salt of acid. Okay, soda salt of acid. This is also not possible. Now, red phosphorus and HI we can use this reagent Zn with conc HCl. What is this reagent? And what is the method we have in which we use this reagent? Can you tell me the name of that process, that reaction? It is Clemmensen reduction, right? If you remember, Clemmensen reduction, the reagent is this, and one more reagent we have, that is NH2 NH2 hydrazine. What is this reagent? NH2NH2 with C2H5ONA. This reagent we use in Wolff-Kishner reduction, right? This is Wolff-Kishner and this one is Clemmensen, right? And Clemmensen reduction, if you remember, it is used for the conversion of aldehyde or ketone, into alkane, right? And in short, what you can memorize, all these compounds, C double bond O converts into methylene group, that is CH2, right? That is what the conversion we have. All other things will be same. But here we don't have aldehyde or ketone, but we have acid, right? So for acid we use red phosphorus and concentrated Hi. So answer will be option C, red phosphorus and concentrated Hi. One thing you must remember, excuse me, I'll tell you in this. If you have alcohol, right, and we are talking about this reagent, ROH, with red phosphorus and concentrated Hi, it converts into RH. If you have RCHO, that is also we use here. Red phosphorus and Hi, if you are using this, again C double bond O converts into CH2. So this gives you RCH3. If you have ketone, then again the same thing, R2CO, same reagent. It converts into R2. The C double bond O converts into CH2. If you have RCOH, then again it converts into RCH3 with same red phosphorus and Hi. Okay, so all these compounds, alcohol, aldehyde, ketone, or acid, converts into alkane when it is heated with red phosphorus and Hi. Right? Answer will be option C. Is it clear? Which one? SVZ. No, you see the product is given. No, you see acid is converting into alkane, right? Acid is converting into alkane, and this is the preparation of alkane you have. If you have revised this chapter, preparation of alkane, the topic will be like this: the preparation of alkane from the reduction of compounds containing oxygen as a functional group. There we have some other reagent also in HVG. You must revise that. We don't have only red phosphorus and Hi present. I think there is I2 also we have there. Yeah, that's with iodine, right? This is the preparation method of alkane from carboxylic acid or any other compounds containing oxygen, alcohol, aldehyde, ketone, or acid. Okay, so you must remember this. Zinc concentrated HCl is Clemmensen reduction, and which is used for the conversion of aldehyde or ketone into alkane, right? So this is the second question we have done. Now you see the third one. Tell me the answer. This is 6, it is written 6, which I think it should be 2. 2 molecules of PHCH3. Yeah, it's toluene. Aditya, Naman, Amog, are you there? Aditya, why it is D? All of you are saying D. Why it is D? Explain this. What is the first product we get here? PHCS3 with Cl2H What is the first product we get? Yeah, it becomes PHCH2Cl. What is the name of this compound? What is the name of the first product will be PHCH2Cl. Tell me the IUPAC nomenclature of this. Correct, correct. Your answer is right. All of you are right. Tell me the name of this molecule. Is it benzyl chloride? What is the IUPAC? Yeah, correct. What is the IUPAC name? Correct, benzyl chloride. Any other name? Can you write down the other name of this one? Yes, phenyl chloromethane also you can write. Okay, that's what I wanted to know, because when this functional group is attached with this molecule, so this becomes the substituents now. And for substituents of when benzene ring presents, no, that's what benzene we cannot use, Shruti, because when benzene is present as substituents, then we don't write benzene in the name of this, but we write phenyl. Okay, so it is phenyl chloromethane. Correct. Phenyl chloromethane is right. Option D is correct. First of all, we'll get this, and then Wurtz reaction takes place. Two molecules of this will join together, and the product will be option D. Right? Question number 4. Decreasing order of boiling points. Is it D? All of you are getting D? Right. Option D is right. See, 2 points. Boiling point is directly proportional. Point is directly proportional to molecular mass. Or we can also say as the number of carbon atom increases, boiling point increases for a straight chain compound. And it is inversely proportional to branching. With branching, boiling point decreases. Correct? So first of all, we have pentane and butane. So obviously butane will have more boiling point than pentane. So C is greater than A. Right? This option is not possible. A is greater than C we have here. Now we have 2,2-dimethyl propane, which is nothing but the isomer of pentane only. What kind of relation between C and D? Can you tell me? What kind of relation we have between C and D? What kind of relation we have between C and D, or you can say among C, B, and D? Can you tell me? They are chain isomer, right? Because the number of carbon atom in the parent chain is different, right? So all these C, B, and D are the chain isomers, right? So in this chain isomer, we know that in isomers, we know as branching increases, boiling point decreases. So obviously A will have the least. C is not N-pentane straight chain compound maximum. Then we'll have B because there is only one branch. This is two branch. So C, B, D, and then A option D is correct. Okay, so they are chain isomers also. Next question. This is a factual question actually. Soda lime decarboxylation. Okay, answer C, option C is correct. Now one more question I may ask you in this one, that in all of these molecule, in which of this reaction or in which of this method will get higher alkane? In which of these methods will get higher alkane? Can you tell me that? Only Woods, only one. What is Cobb electrolytic method? Urge is fine, it's correct. We all know. But what is Cobb electrolytic methods? D. Only D. Aditya. See, first of all, the answer of this question is soda lime decarboxylation, and the reaction is this, which we have already seen just now: CH3COONA plus NaOH. When you heat this, we'll get CH4 and NO2CO3 forms. Right? So get methane into this. So answer is option C. Wood's reaction will also give you higher alkane. Kolb electrolytic method will also gives you higher alkane. Okay, I'll just write down. No, not D. It's A and B. See, what is this Kolb electrolytic methods? If you have salt of sodium or potassium, suppose I am taking sodium only, salt of sodium and potassium. When you do the electrolysis of it, then we get R plus CO2 plus NaOH plus H2. Right. This reaction actually follows free radical mechanism. All these information you must have free radical mechanism. And since we have electrolysis, so you must have some reaction at cathode and will have some reaction at anode. Right? So at cathode, the reaction is this: is this metal you have Na plus accepts an electron and forms Na radical. Na radical. Okay, this Na radical takes H2O and forms NaOH plus half of H2 hydrogen. Anode reaction is this: the anion we have RCOO minus releases one electron because oxygen has one extra electron to this. That's why we have negative charge here, and forms RCOO. This oxygen has one unpaired electron and two electron will be as it is. So this is again a radical we have. And from this, we know radical has this property to eliminate a neutral molecule to form a new radical. So it eliminates CO2 to form alkyl radical. Now in this alkyl radical, coupling reaction takes place. So R radical combines and forms higher alkane. So what is the point? Why I have written these equation here? Because sometimes they ask this question that Kolb electrolytic method, what is the mechanism? Free radical mechanism. First of all, this question you must keep in mind. And sometimes they ask this question also, at cathode and anode, which gas evolves? At cathode and anode, correct? So at cathode, we can see hydrogen gas evolves, and at anode, carbon dioxide gas evolves. Okay, so these two products will get at anode, and these two products will get at cathode. Right? So the kind of question they are asking nowadays, you never know what they are going to ask. Right? So all basic, small information you must have. Clear? Write down this equation and you must memorize these 2-3 points. Right? Can we move on? Question number 6. Okay, you haven't done this kind of question, right? Right, okay. We'll do this. So write down, see, first of all, this compound, which is N-hexadecane, is nothing but cetane. This compound is cetane. Okay? Okay, so write down this one. The cetane number is defined as number is defined as the percentage by volume the percentage by volume of cetane percentage by volume of cetane in a mixture of cetane. Why I'm writing this N always? I don't know. This is also not there. In a mixture of cetane and this compound, alpha methyl naphthalene. Alpha methyl naphthalene. Okay, so cetane is nothing but N-hexadecane, right? Now you see this question, the percentage of the latter is 10%, right? So this is given the volume percent of the latter, means this compound, alpha methyl naphthalene, the percentage of this is given, which is nothing but 10%, right? So what is the cetane number? It is defined as the percentage by volume of cetane in a mixture of this. So if 10% by volume methyl naphthalene is present, so this cetane is present what? 90% by volume. Answer is option B. Generally, this kind of question they don't ask, but I have, I took this question because you like the question, the way they are asking the question, you cannot skip any small information also. That's why I took this question. Understood? So cetane is N-hexadecane and cetane number is the percentage by volume of cetane in a mixture of cetane and alpha methyl naphthalene. Correct? Option B is right. Definition, all of you write it down. Next question. Highest boiling point. B. I don't think I have to discuss this. Okay. Maximum molecular mass. B. And its straight chain compound. Question number 8. Do this one. Question number 8. B is right. Next question you do.
गया सर क्लास
नहीं
आप आ रहे हो ना हो गया नहीं नहीं मेरे को आगे ना जाना है
Vaishnavi is getting C, 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 C. All of you are getting C, tell me. Okay. Can you tell me in first option, that is 2-methyl pentane, how many monochlorinated product we get? In first option, how many monochlorinated product we get? Tell me the first one, second one, third one, and fourth one. For all these compounds, how many monochlorinated products possible? 6. Now you're getting different answers. 6, 4. Check your answer.
बोल दिया मैंने बोल दिया वो प्रोडक्ट कल कर दूंगा हाँ तो सामने बोल दिया मैंने अभी मेरा बोल रहा हूँ उसको बोल रहा हूँ तो अभी तो बोलने जा रहा हूँ
Is it 6, 5? Aditya and Vaishnavi is getting 5. 5 is the right answer. You see, 2-methyl pentane. So pentane is this 1, 2, 3, 4, 5, and here we have methyl, right? So this position we can have chlorine attached over here. One position is this. These two are equivalent position, right? So 1, then 2, then 3, 4, and 5. These two are equivalent position. The name of this, if chlorine attached here, the compound is what? 1-chloro-2-methyl pentane, right? And if chlorine attached over here, then it will be 2 plus 5, 7, and 1 plus 2, 3, 4, 4, 5. So we'll count from this side. So 1-chloro-4-methyl pentane then, right? So total 5 monochlorinated product possible in the first one. What about the second one? 2,2-dimethyl butane. Butane is this 1, 2, 3, 4. Here and here we have methyl. So you see here again, these three positions are equivalent, right? 1, 2, and 3. Equivalent position. So the different product we get when this will attach, one chlorine will attach over here, and then one chlorine will attach over here, and then another chlorine attaches over here. So this 3 gives you 3 chlorinated product, 1, 2, and 3. Okay, these positions are equivalent position, 1, 2, and 3. So you'll get same product here. C is 2 already, right? N hexane if you have, then again we will get 3. N hexane also, or here also will get 2, sorry, here also will get 3, here will get 2, and here will get 3, right? So see, this kind of calculation is also important, because in this only they can ask this question also, that which one of these molecule gives the maximum number of monochlorinated product, or they can also ask you minimum number of monochlorinated product, right? So that's why this calculation is also important, right? Correct answer for this question is option C. Next, question number 9. You must have done this kind of question. Neopentane, correct? Neopentane is this. You see, all carbon positions are equivalent, right? 1, 2, 3, and 4. Equivalent carbon position we have, okay? That's why we'll get only one monochlorinated product here. Answer is option D. Just a second. Okay, you understood this, no? Next question you see. Aditya is getting A. Why A? Can you explain, Aditya, Ritvik? Transposition. Yes, correct. Trans molecule, we have minimum steric hindrance and maximum stability, right? Do you see across how many stereo center we have in these compounds? First option, how many stereo center we have? Correct, correct. How many stereo center in the first one? Both double bond, right, Saundarya? Okay, this is the stereo center and this is the stereo center. Right, so across this double bond and this double bond, GI is possible, geometrical isomerism. Right? Why? Because the both carbon atom contains two different group at it. I hope you remember all this because I have discussed this in the very first or second class of yours, right? Geometrical isomerism. I have discussed all the three condition of GI. Correct. The true stereo center we have this across this double bond. If you see, the molecule is trans, right? Because higher priority on the opposite side. Trans, or we can also say anti, right? Anti would be better. Here also you see it is also trans or anti, right? So both across both the carbon atom we have trans position or anti position. So it is most stable, minimum steric hindrance, and hence it is most stable. Correct. Here you see these two are at cis position. This across this also we have cis position. Across this also we have what? Across this we have trans, but across this we have cis position. Correct. Only these two steric center that you have at those steric center, at both the steric center, we have transposition. That's why this is the most stable conformer, least steric hindrance. Okay. Option A is correct in this. Okay. So what we can write, trans gives you least steric hindrance and hence most stable. That's why option A is correct. Okay. Question number 11. Next one. 2-phenyl propene on acidic hydration. Write down the structure first of this molecule and try to get the product. Most of you are getting A. 2-phenyl 2-propanol. Okay. 2-phenyl propene is this. When you do the acidic hydration, which is nothing but the reaction with H plus H2O, right? So this reaction follows electrophilic electrophilic substitution reaction, or we can also write it down electrophilic reaction mechanism. And we know this electrophilic reaction mechanism follows by the formation of carbocation, right? And this carbocation should be, if possible, most stable, right? We'll try to form more stable carbocation and then we'll get the product. Okay, so what happens in this reaction, you see, this double bond will shift over here, right? And we'll get the positive charge on this, which is a carbocation, right? Or what we can say, this double bond will take this H plus actually. This H plus will come over here, this double bond shift here, negative charge will take this H plus, so we'll get CS3 over here. We'll have the carbocation over here. And this carbocation, like this, you can write down. I'm writing down all the steps here. CH positive charge, single bond CH3, single bond CH3. And in this, you have H2O. So H2O is this lone pair on it. Now this lone pair will attack onto this carbon atom, and the product we get here is this. Positive CH3. And finally from this, since this oxygen has positive charge, least stable, H plus comes out and we'll get the product as. So answer is 2-phenyl 2-propanol. It's correct. So all of you are saying A only. It's correct. Those who have got B, you can understand from this mechanism. Is it clear? Next question.
But my phone is just here because you need call morning and I can give you.
Is it B? Simon, you are getting C. It is not aqueous KOH. See, it is ethanolic potassium hydroxide. Okay, ethanolic. The purpose of this is what? The medium is alcoholic. That is it. So we have alcoholic KOH, right? And alcoholic KOH gives you alkene, not alcohol. If you take aqueous KOH, then you will get alcohol, right? So answer in this will be propene. Got it? I'll write down here alcoholic KOH gives you alkene. Aqueous KOH gives you alcohol. Right? So here we have alcoholic KOH, so we'll get propene with equal number of carbon atom. Correct. So option B is right. Is it C? Tell me others. What is the answer you are getting? What happened? Others, tell me. What happened, guys? Okay, you see, A gas decolorizes alkaline KMnO4, right? So when this decolorization takes place, it means the gas must be unsaturated. The gas is an unsaturated compound. It is an unsaturated compound which can be alkene or alkyne. Correct? Unsaturated compounds may be alkene or alkyne. Okay? So this is the test of unsaturation if you remember. Double bond and triple bond, the presence will identify with the help of alkaline KMnO4 and when decolorization takes place. Correct? So obviously when you are sure with this unsaturation part over here, so you can easily eliminate two options into this, that is A and D, which are alkane, right? CnH2n plus 2. It is methane, all single bond, and this is ethane. These two cannot be the answer. Now we are left with alkene and one is alkyne. Now you see next thing here, alkynes or terminal alkynes. Okay, the next part we have got terminal alkynes, which is nothing but the option C. It combines with sodium and sodium compounds and the silver compound like this here we have, and forms sodium or silver salt of sodium, or like in this one what happens, the CH triple bond C minus Ag plus will get here, or if you have sodium then we'll get Na plus over here, means salt of these elements will get only terminal alkyne, you must remember, not all the alkynes. We're talking about terminal alkynes now. Okay, must keep in mind. But this, what happens, the alkene that you have, this not at all reacts with AgNO3. So find these two compounds can show decolorization with this KMnO4, but since C2H2 reacts with AgNO3 and forms the salt of silver, that's why this option is not true, but C2H4 is true, right? For example, you see this reaction C2H4, which is nothing but C double bond CH2 H2, and this reacts with alkaline KMnO4, right? So we have KMnO4, alkaline medium. We'll get diol in this case, right? That is CH2, single bond CH2, OH and OH, ethylene diol. Okay, but this does not react with AgNO3. With AgNO3, no reaction. But if you take alkyne over here, that will form salt of silver. That's why option C is not correct, B is the right one. Fine. All these are property reaction of alkene and alkyne. You must you probably did not revise those chapters. That's why you are missing all these, right? But no worry, you can memorize all this now. Also, you can keep in mind, take note of all this, and that will help you in the coming exam. Next question you see. Anti-Markovnikov addition of HBr. Easy one. Do it fast. We have to finish till 30 before the break. C option is correct. So you should not have any doubt in this one. Anti-Markovnikov addition, you know that the negative part of the reagent will attach at the double bonded carbon atom which has more number of hydrogen. Correct? That is anti-Markovnikov rule. Anti-Markovnikov addition is possible in case of HBr only. That is only in presence of light. We can also write H nu, light or H nu, or in presence of peroxide. This point to write down. Okay. Anti-Markovnikov is only valid for HBr. Addition of HCl, HI, HF does not follow anti-Markovnikov rule even in presence of light or peroxide, right? So this is one important thing we have, and you must keep in mind this thing they have asked many times in various examinations. Okay, a reason if you want to write why HCl, HBr, HI does not show anti-Markovnikov addition even in presence of light and HBr. The reason is actually not important, but if you want, you can write it down. I'll just give you. Write down this. See the light that we are using here, in presence of this light, because of the wavelength of the light, the molecule HBr dissociates in its ion form, H plus and Br minus. And then the reaction proceeds. Okay, it's not ions, actually it is radical. We should write down it as radical, not ions. Okay, so the homolysis happens over here and we'll get hydrogen and bromide radical over here, right? But in case of HF, HCl, HBr, what happens? The bond strength order, if you see, it is maximum for HF, then we have HCl, then we have HBr, and then we have HI. Relative bond strength is this, right? So the molecule HF and HCl its bond strength is too high so that it does not break in presence of light, right? In case of HI, what happens? The bond strength is low of HI, right? But since iodine is a bigger molecule, we have iodine the bigger atom, right? So the being bigger in size, the I radical is not that much reactive, right? Okay, fine. Just write it down. First of all, write down this one. The bond strength of HF and HCl is strong enough so that it won't dissociate in presence of light. Correct? That's why this two does not show anti-Markovnikov addition. HI, the bond strength is, the bond strength is actually it is weaker than HBr, so it will dissociate in the forms of its radical, right? But since the size of iodine is big, right? Iodine has a bigger size, so it is highly reactive in nature. So again, the two iodine radicals combines and forms iodine molecule I2, right? That is why HF, HCl, HBr does not show anti-Markovnikov addition even in presence of light or peroxide. Okay, simply you have to memorize this. Now coming back to this question, anti-Markovnikov addition of HBr is not observed in Anti-Markovnikov addition, one more point to write down, right? You should not have any confusion. Anti-Markovnikov addition, and this is only possible for HBr, which we don't need to write actually. Anti-Markovnikov addition is possible only in unsymmetrical alkene. Unsymmetrical alkene, right? You see, all these alkenes are unsymmetrical except the third one, butene. That's why the answer is option C. Correct? Next question. Tell me this one. All of you are getting C. Okay, first of all, I'll write down the structure of this molecule. Butene, right? So we'll have CH3, CH, CH double bond, CH2. Here we have CH3, CH3. It is 2,3 dimethyl butene. And when you do the ozonolysis of this, that is O3 with, and then we use what? Zn and H2. The method to write down the ozonolysis product is what? The carbon atom which is attached with double bond, just break this double bond, add double bond O to this carbon and double bond O to this carbon. So what we'll get here, you see? CH3, CH, CH3, C double bond O, CH3H. This is the first product. Another product is this HC double bond OH. So you'll get methanol and 1, 2, 3, 3 methyl, 2 butanol, right? So option C is correct. All of you have got the right answer. Yeah, option C is correct. 2-butanone. Next question. Tell me the answer. See, HOBr is nothing but HO minus and Br plus, right? Or this reagent we can also write it as Br2 with NaOH. Sorry, Br2 with NaOH, right? Okay. So now whether you have this molecule as the reagent or this as the reagent, both gives you the same product. Okay, because these two reacts and gives HOBr only. Correct. So the addition of these to any alkene follows Markovnikov rule. That you have to keep in mind. Markovnikov's rule. Okay. So now you see the propane is CH3, CH double bond CH2 with HOBr, with negative part is this, positive part is this. So we know according to the Markovnikov rule, negative part of the reagent attacks on the double bonded carbon atom which has lesser number of hydrogen. So OH minus will attack over here and Br will attach over here. The product here it will be CH3CH, CH2Br, OH. So 1 bromo, 2 propanol. Right? Answer is option D. Correct? Yeah, right. Option D is correct. Next one. Question number 17. Sorry. Hello? Yeah. Yeah. Tell me. Uh, Actually, right now I'm not planning to buy any bike. Thank you. Why does negative charge go to OH? Because oxygen is more electronegative than bromine. So the pair of electron will get attracted towards the OH group. Understood, Aditya? Since oxygen being more electronegative, so that will attract the bond pair of electron, and that is how the bond dissociate. See what happens. Here you see we have bromine, right? Br. So this will dissociates like one of the bromine will take this. Here we have heterolytic cleavage. So we'll get Br plus, and one of the bromine atom will have two electrons and negative charge on it. NaOH gives Na plus, so this Na plus will take this Br minus, forms NaBr, right? And OH minus, this will attach with this, so form HO or OH minus HOBr. That is how it happens. Correct? Next one, what is the answer? Yeah, right. The answer is option B. Why this one is C? First of all, the intermediate formed during the addition of HCl, propane, principal peroxide. First of all, we have peroxide here, but since HCl we have, so this won't follow by the anti-Markovnikov addition will not be there, right? So propane is nothing but CH3 CH double bond CH2, right? So addition takes place according to Markovnikov rule. Means negative part of this, which is Cl minus and H plus, this will attach at this carbon only. But what is the intermediate product? Since it is not the it is not the anti-Markovnikov addition. It is simply the ionic reaction we have. Means the reactant or intermediate product that you have, that will present in the form of ions. Okay, we'll have heterolytic cleavage into this. So this bond pair will shift over here and will get positive charge on this carbon atom. So we'll get CH3 CH plus CH3, right? This H plus will come over here. Okay, H plus. So this is what the intermediate product we have, and finally on this Cl minus will attach, we'll get the final product. So intermediate product will be what? Option B. Correct? Ionic reaction possible in this, since HCl does not follow anti-Markovnikov addition, right? So free radical does not form in this reaction. Heterolytic heterolytic cleavage takes place into this, and then the reaction proceeds. Always keep this thing in mind, that addition of HCl, in presence or absence of peroxide or even light also takes place, or we can write down like this, occurs by ionic mechanism. Ions forms into this. Okay, and we'll get option B as the product. Next question. Question number 18. What is the answer? See, the reactivity of alkyl halide reactivity of alkyl halide is inversely proportional to carbon halogen bond strength. More will be the bond strength, less will be the reactivity, right? So we know bond strength, as we go down the group, size increases and bond strength decreases, correct? So the bond strength order is what? For carbon and chlorine, it is maximum, then chlorine and bromine. After this, we have carbon and iodine. This is the bond strength order. So reactivity will be reverse of this. So order of reactivity will be carbon chlorine, then carbon bromine, and then carbon iodine. This is the reactivity of alkyl halide. And one more thing that you know, that iodine is the best leaving group. That is why, because you can dissociate this bond easily, right? When this bond dissociates, then only reactivity or reaction proceeds. So that's why the reactivity is this. Option B is right. Next question. This, for this one, it is A, Aditya, right? Okay. See, in this question, when you have this Cl2 and AlCl3, in this only one chlorine atom will attach. Okay, so chlorination takes place. Monochlorinated product will get. Chlorination takes place with this reagent. If you have Cl2 with H nu, or again this one you see, it is actually the same as HOCl. Right now we have discussed. Okay, HO minus and Cl plus. Okay, so in this OH and Cl minus will attach. So this is also not true. This is also not true. Right? Chlorination in presence of light gives you again one monochlorinated product into this. Okay, so this is also not true, because we have to add chlorine at both double bonded carbon atom, and that is only possible by ionic reaction or ionic mechanism, and which is can be possible with presence of chlorine only, right? Chlorine atom, like I have already told you just now, chlorine and chlorine molecule, heterolytic cleavage takes place and forms Cl plus Cl minus. Okay, and then first this molecule will attach with this double bonded carbon, and later on Cl minus will also attach and will get two chlorine atom attached with this carbon atom. Correct? And we get this product. Right? So option A is correct in this case. 19th D is not possible. I just now I have discussed this Saundarya. OH minus and Cl plus. One carbon will take OH, another carbon will take Cl. Correct? Next question you see. Pentyne to pentanol. Okay, what is the answer? We have to convert triple bond into, what is this reagent to HgSO4 and H2SO4? Okay, you see in this reaction, first of all, the simple one we have, if you have pentyne, correct? So the reaction is this CH3, CH2, CH2, C triple bond, CH. Right. In this, the first reagent that we use, or whenever you use this BH3 with H2O2 in basic medium, which is NaOH or OH minus, then what happens? Addition of H plus and OH minus ion takes place, and that follows anti-Markovnikov addition, right? So on this carbon, you see, if you have this reagent, you can go through the notes. We have already studied this. Okay, this reagent gives the addition of H plus and OH minus. You'll get alcohol over here first, and this addition follows anti-Markovnikov addition, right? So you see these two carbon anti-Markovnikov addition we have. So negative part will attach at the carbon which has more number of hydrogen, correct? OH minus will attach over here and H plus will attach on this carbon atom. So the product here it will be CH3CH2 CH2CH double bond CHOH. Okay. Now here what happens? Tautomerism takes place, right? So this bond pair comes over here, and this hydrogen will jump onto this carbon atom, alpha position. So we'll get CH3CH2 CH2CH2 CHO, which is nothing but pentanol. उसको भी हाथ जोड़ेंगे right? So answer will not be HgSO4 and H2SO4. Okay, most of you are, saying option A. Okay, I'll share you one link. Okay, that you go through. You will understand the mechanism of this reagent, how this reagent reacts. Okay, so I'll share this link on WhatsApp. Just now I'm sharing. Okay, you can go through it. If you have if you have doubt, you can ask me. Okay. Okay, I have since most of you, yeah. That's why I have shared the link. You can go through. Okay, on your WhatsApp, you will understand the mechanism of working of HgSO4 and H2SO4. Correct. You go through that. There is a mechanism. It is given over there. Okay, so you go through that mechanism. You will understand that. Correct. Just you go through once. Okay, if you have doubt, then you can ask me. I'll explain that. But the whole mechanism is given in detail. Okay, we'll move on next. Okay, for this the answer will be option D. Right? Why not A? You will understand once you see the mechanism. Okay, that you go through once. Next question you see. Question number 21. Do this fast. This one is good. Tell me the answer. Tell me what is the answer. Okay, see, I'll solve this question. First of all, you see the hydrocarbon A on ozonolysis give two isomeric forms of B and C, right? And those isomeric forms will be what? What are those isomeric forms? Obviously, that can be aldehyde or ketone, right? Because we can convert these into each other easily, right? We'll see that also. So first of all, we'll get two isomeric forms B and C. B on oxidation gives D. Silver salt of D contains 59.6% of Ag. So fine, you see the silver salt of D contains 59.6% of G. Okay, so this is actually mass percentage. It should write down over here the mass percent of it. It is understood actually here, right? So the salt of silver that you have, which is nothing but RCOOAg, the salt of silver. In this, if the mass of this is 100 gram, if I take, then the mass of silver present into this is 59.6 gram. Mass of silver, right? So the atomic mass of silver is 108. So for 108 gram of Ag, what should be the mass of this salt we have? Right? So which is nothing but 100 divided by 59.6 into 108. Right? When you solve this, you will get 181 gram. So the molecular mass of salt is 181 gram. This is the molecular mass of silver salt. Correct. So if I try to find out the molecular mass of acid, from which the silver salt has been formed, what is that? That would be the molecular mass of silver salt minus, we can subtract the molecular mass of, we can subtract the molecular mass of silver from it, plus 1. This silver you remove, add H over here, you will get acid. Correct? So molecular mass of acid is this. When you solve this, you will get 182 minus 108, which would be around 74, I guess. Right? So it is 74 gram of the acid. Right? So acid must contains COOH, first of all, you see C double bond O, OH, and then here we have one alkyl group, so that the molecular mass is 74. So by, like, when you by hidden trial, what we can say, the molecular mass of this part will be what? Carbon is 12, it is 16 into 2, 32 plus 12 is 44 plus 1 is 45. Right? 74 minus 45 is what? 29. Now in this 29 we can have 2 carbon plus 5 hydrogen. This gives you 29. So what we can say, it is CH3 CH2. So the molecular mass or the molecular formula of acid will be CH2 CH3 COOH. This is the acid you have. I don't know whether you have solved this kind of question or not. This is nothing but gives D, right? So this is nothing but D, the acid that we have. Right? Now, since D on oxidation gives acid, B on oxidation gives D, right? So oxidation, B gives you D. If D is acid, this must be aldehyde. And what is the formula of that we can write? CH3CH2 CHO, aldehyde. And aldehyde are the functional isomers of what? Ketone. So the another formula of ketone will be what? We have C double bond O, because we have 3 carbon, right? So C double bond O, CH3 CH3. Acid, aldehyde and ketones are isomers of each other. This is C probably, right? Now A on ozonolysis gives B and C. So these are the product we have. Or better if I write down like this: C double bond O H. Can you write down the formula of A, which on ozonolysis gives these two product? Did you understand this? A on ozonolysis gives these two product. right? So what would be A? We'll add this carbon and this carbon by double bond, correct? So the formula of A will be CH3C CH3 double bond C CH2 CH3 and hydrogen we have here. The answer will be what? I think option B. Correct. Is it clear? So little bit of calculation we also had in this question. Can we move on next? Let me know if you understood this. Question number 22. You're getting D. See, first of all, cyclohexene is this. On ozonolysis, the product here we have is here we have CHO and CHO, correct? Now this compound further treated with aqueous KOH. So if you remember, aldehyde with alpha hydrogen reacts with aqueous KOH. This gives intramolecular aldol condensation reaction. Intramolecular aldol. Mechanism I have discussed in the class. Correct? Intramolecular aldol. So this base OH minus will take the alpha hydrogen from here and will get a negative charge over here. CHO with a negative charge, and this CHO will be here. Now this intramolecular means what? This negative charge will attack onto this carbonyl carbon, right? Carbonyl carbon over here. So what happens here, you see, 1, 2, 3, 4, 5. We'll get a 5-membered ring. Right. And sorry, I should write down like this. Should be this, no. We have CH double bond O. So when this negative charge attacks over here, this bond comes over here, right? And here we have carbon. This carbon will have this hydrogen over here. So we'll have OH. And this carbon, this CHO group will be as it is here. Right. Now in this what happens? Dehydration, H2O molecule goes out, goes up because it's what? Aldol condensation. This is aldol reaction. Alpha hydroxy aldehyde or ketone is aldol, right? So now in this condensation takes place, H2O molecules goes out, right? So H2O molecules goes out from this carbon, and the product will be this. We have a double bond here and CH. So hence option A is correct. Correct? Understood? Next question. Tell me the product quickly. NO minus and Cl plus. Finish this one, then we'll get a break. We'll take a break then. So what is the answer in this? All of you are getting B. See, the other molecule was HOBr. Right, then we have taken HO minus Br plus. NOBr or NOCl. Right, we call it as nitrosyl chloride. Nitrosyl chloride. We also call it as Tilden's reagent. Tilden's reagent. And this reagent follows electrophilic addition reaction. electrophilic addition reaction, right? And in this one, it dissociates like this. We have NO plus and Cl minus. Even NOBr also dissociates with the same fashion. NO plus and Br minus. Right. Now in this, the double bond will shift over here. We'll get positive charge over here. Cl minus will attach here and NO will attach here. We'll get option A as the answer here. Right. In case of HOBr, it is fine. HO minus and then Br plus because we have hydrogen over here. Okay, so you must keep this difference in mind of HOBr and NOBr, nitrosyl halide that you have. Okay, we'll take a break now. We'll start in 15 minutes. Okay, 6:30. We'll start in 6:45. Fine. We'll start at 6:45. Guys, are you there? Can we start? What is the answer? You're getting B. Two gases P and Q decolorize aqueous bromine, but only one of them gives a white precipitate with aqueous ammoniacal civil nitrate solution P equal to B. Okay, so first of all, since it decolorized aqueous bromine, so the compound must be unsaturated, right? So we cannot have any alkane possible here, right? So A and C options are wrong directly. Ethine and propine, right? Here you see, here we have alkyne and alkyne. So but one ine gives you what? The silver salt of that, right? Which is the white precipitate, and this you'll get the another compound into this one. Correct. So the terminal alkyne, that is but one ine, and the other one is non-terminal alkyne, right? So the white precipitate which aqueous unsaturated solution gives, P and Q are likely to be. So the terminal alkyne gives you the white precipitate, and other compounds will decolorize the bromine water, right? So in this you see we have ethine and propine, correct? So both are actually terminal alkyne, right? So both should give the white precipitate with this salt, which is not the condition we have, because it says only one of them, right? So we should have only one terminal alkyne, and that is only possible in case of option B, right? So option B is correct. Most of you are getting the same. Anyway, so we'll move on. Question number 26. Tell me fast this one. What is the answer? 26. B. Okay, option B is correct. You see, in this question, first of all, this carbon is sp hybridized. This carbon is also sp hybridized, and this one is sp3 hybridized. Okay, so we know the negative charge on more electronegative element is more stable. So sp is more stable than sp, more electronegative than sp3. So obviously B and A is more stable than C. Correct? So B and A is more stable than C. So we can easily eliminate these two options. Right? So C is the minimum we have here. C is the minimum we have here. Now, in next one you see B and A, if you compare, CS3 has electron releasing nature. And because of electron releasing nature, this will be little bit less stable than this one. Because of electron releasing nature, it will increase the electron density, and hence hence the stability decreases. Hence option B is correct. B is most stable, then A, and then C. Correct? Question number 27. It's a direct question. What is the answer? Question number 27. Hot alkaline KMnO4. So oxidation takes place. Why it is C? Why A, Shreyas? See, 1-butene is nothing but this CH3, CH2, C triple bond, CH. When hot alkaline KMnO4, if you are using, so this forms acid, right? And the product will be with equal number of carbon atoms, CH3, CH2, COOH, plus the other product will be HCOOH, right? Other product will be HCOOH, right? So you'll get this product in one step, in single step, right? Sometimes what happens, these two also react, but not completely, and converts into CO2 and H2, right? So we'll have little bit of this also present, and with this reaction, we'll get CO2 and H2 also, right? So we can have any one of these as the answer, option C and option D. right? If I have to choose one in these two, I'll go with option D, right? Because they are not talking about the final product, it is not mentioned. It's just simply like one butane on oxidation gives what, right? So this double bond will break, we'll get COH here, COH here, the product will be this. Sometimes in some book it is written also that these two also react, and some part of it converts into carbon dioxide and water, right? That is how the reaction goes. But I'll go with option D in this one. Correct. Next question. 28. Tell me this one. The answer B you are getting. Okay, the correct answer is B only. This is the hydration, obviously H2OH plus. This is what hydrogenation H2PD. This is the chlorination reaction, which is nothing but halogenation. And D is nothing but the polymerization. Three molecules of this polymerization takes place, right? So option B is correct. That question is easy one. Next question you see, question number 29. The hydrocarbon which reacts with sodium in liquid ammonia. It is also a direct question. And we have discussed this also so far. Tell me. Yes, option C is correct because terminal alkyne is required. We have discussed this today also many times that terminal alkyne forms salt with sodium and silver compound, right? So you'll get C plus, C minus, Na plus over here, right? The hydrocarbon which reacts with sodium in liquid ammonia is nothing but terminal alkyne you have to keep in mind, right? So option C is correct. Okay, so in this one, the product you will get here is CH3 CH2 C triple bond C minus Na plus. Right, terminal alkyne only reacts with forms salts with liquid sodium in liquid NH3. Correct. So option C is correct. Question number 30. Tell me the answer. Question number 30. You see this RMGX. This is minus and this will have plus, right? And since it is a terminal alkyne, right? So it can easily protonate the RMGX over here because this hydrogen is what? This hydrogen is slightly acidic. And why it is an acidic hydrogen? Because this carbon is sp hybridized. Okay. So since the terminal alkyne again we have here, so hydrogen is what? Acidic. So what we can say, the terminal alkyne can easily protonate the Grignard reagent. So write down this point here. Terminal alkyne can easily protonate Grignard reagent. Protonation means what? Addition of H plus, right? So this H will come out and joins with this CH3 minus, forms CH4 plus will get CH3C triple bond C MgX. This is the product we get here. So option D is correct in this one. We'll get methane. Always remember one thing, Grignard reagents, from Grignard reagents, if you are getting alkane, the alkane will get with respect to the alkyl group of Grignard reagent. Okay, option D is correct over here. Fine. Next one. Tell me this one, I think you can do easily. Addition of HBr follows Markovnikov rule since there is no light or peroxide we have. Just you add Br minus an H plus. Do we have any rearrangement in this? If yes, then what kind of rearrangement you have done? You're getting option A. Yeah, option A is right. What kind of rearrangement we have done in this? Option A is correct. I'll write down here. You see, first of all, Br minus will attach at the second carbon. So we'll have Br here. Right? Double bond will get CH2 here. Right? Since we have one more molecule, so again the shifting of pi electron will take place, right? And this electron will shift here, will get 3-degree carbocation, and finally the bromine attached on the second carbon. So CH3 CBr, Br CH3 with another HBr molecule. So it is 2,2 dibromopropane. Option A is correct. Similarly, you can cross check other option. Yes, hydride shift is there. Right, we have one hydrogen here. So we'll have the hydride shift finally. So we'll get this. Correct? So hydride shift will do to get the more stable carbocation. Understood? I'll write down thing here. H plus. This H plus will come. So I'll get CH3, CH plus Br. Think here we have CH2 plus. Like this, you will get the product. Then hydride shift will be there. You'll get 3-degree carbocation and again HBr attacked into this. Next question we'll see. Which of the following has minimum boiling point? Tell me first. Minimum boiling point. It is minimum boiling point, Shreyash. Read the question properly. Minimum boiling point. Right? So maximum branch will have the minimum boiling point. Right? So it should be option D. Isobutane. Butene. Correct. With branching, boiling point decreases. Next question you see. 34. 34 and 35. Tell me these two questions. 34 and 35. 34 is A. Okay. What about 35? 34A is right. Both assertion and reason are correct. Right? And this octatetraene is a non-planar molecule. Having 8 pi electron, it is not an aromatic compound. Okay, remember this one also. Non-planar octatetraene having 8 pi electrons and not an aromatic compound. So 34A is correct. What about 35th one? Nitration of benzene with nitric acid requires the use of concentrated sulfuric acid. It's fine because for nitration of benzene, we need this the mixture of HNO3 and H2SO4. So for 34th one, option A is right. I'll write down the answer at least. That is option A. So for nitration, we'll use this. Okay, and how this reaction proceeds? From this, we'll get NO2 plus HSO4 minus and then H3O plus. Right? If you want to write down the balance equation, is OH minus NO2. So OH minus and H plus from this will get H2O then. H2O. right? So this is what this NO2 plus is nothing but the electrophile. We call it as nitronium ion. Nitronium ion. Now this ion only attach on the benzene ring and the reaction proceeds, right? So that's why the first CUC, first assertion we have, the nitration of benzene with nitric acid requires the use of concentrated sulfuric acid. This concentrated sulfuric acid helps in the formation of nitronium ion, right? It takes OH minus from this, forms H2O, and will get nitronium ion, right? So assertion is right. The mixture of concentrated sulfuric acid and concentrated nitric acid produces electrophile NO2 plus, which is also correct. We have here, right? Hence, assertion and reason both are correct, right? And R is obviously the correct explanation of A. So for this one also, the answer will be option A. Is it clear? Fine. Right. So we'll wind up the class here only. In this particular chapter, we are left with 7 8 questions. Right. So I have to discuss one small concept into that one particular question you may get from that particular concept. Okay. So we'll discuss that concept in next class. We'll solve one or two questions on that also, and then we'll do some chapters of 11th class next class. 11th class, we'll do some chapters. Okay, in the next online session. Correct. So probably the chapter will be states of matter. Okay. So if you can revise, that would be better. Okay, because we'll directly solve the questions. Okay. So okay. So we'll see you in the next class. Okay. First, in the next class, we'll solve these 7 8 questions. One concept I'll discuss, and then we'll move on to states of matter most probably. Okay. Thank you all for joining.